All right, students, welcome back. All right, we're doing page 3, problem 1, cheat sheet for week 7. And the problem says, this comes from January 9, 2019 Regents. So we have a scientist at a local preserve. They're studying populations of 2 insects. Let's just say one is population A and the other population B. They study a sample of 200 of each species of insects. The population of species A insects doubles every week. The population of species B increases by 1,000 insects each week. Okay, so let's kind of think about it in our head, what's going on here. So we have 200 species of insects. We have 200 insects altogether. 100 is in sample A and 100 is in sample B. What we have to do is model the functions of each samples. So how might we best accomplish that? Pause the video and think about if we could create a rate table that would mirror what's going on here. Okay? All right, pause the video and then come on back. Okay, welcome back. So we were told, let's start with sample A. We were told that in sample A, that we're starting with 100, and it doubles every week. So what would that look like? That would mean in week 1, we start with 100. Week 2, it doubles to 200. Week 3, it doubles to 400. Week 4, 800, et cetera, et cetera. So how do we get that? Where's our starting point? Well, our starting point should be for us to go to our stat key, hit edit, and just manually plug in those numbers. Okay? For week 1, we have 100. For week 2, 200. Week 3, 400, and so on and so forth. And then we're going to ask ourselves, we're going to do a regression. All right. Now, is this a straight line or a curved line? I mean, are we increasing by a constant rate? No, clearly not. So we know it can't be linear. So, we have to choose, is it quadratic or is exponential? Well, part of what, if we're looking at this, we could figure out is, well, what would a quadratic and exponential look like? Well, let's start with an exponential. We went to an exponential. Let's see if I did that right. No, I didn't. Clear it out. Stat. Okay. Enter. So that means my A would be 50 and my B would be 2. Okay, so what would this look like in my calculator? I'll pause the video. And so this would look like this in my calculator. Okay, and let's see if those numbers line up with what, we just modeled. Okay. Perfect. That works. So I don't even have to try the quadratic because the exponential has worked so well. So the key question now is this. The question is, after how many weeks? Right? So we're supposed to write the function, okay? And so the function that we will use here is simply take that, paste there. Welcome to our function. Okay. All right. Which species of insects have grown at a larger population after 8 weeks? Okay, so 2 things are still happening. I got the function for A. I still need to get the function for B. But just while I'm covering this, let's figure out where we are with this after 8 weeks. Okay, that's where we are after 8 weeks. Let's copy that. Okay. All right. Now let's consider the other function. Okay, welcome back. So let's see. So for population B, we also started with 100. Okay, and each week we add 1,000. So week 2 would be 1,100. Week 3, 2,100. And let's figure out what this would look like as an equation. Okay, welcome back. So what was it like this? So we go to edit. Okay, so we go to stat calc. We go to for linear equation, and boom, that's what we get. So my starting value is negative 900, and then my rate of change is 1,000. We put that in our calculator. Okay, and let's go ahead and copy that. So we have comparison and contrast. Here we are. So my second equation looks like that. Okay, what's the deal? So after 8 weeks, where are we? Let's figure it out. After 8 weeks, there we are. Let's compare that. And, at home, guys, as you guys are looking at this, not that you will know all of this ahead of time, but just it's about practice. The more you practice, the more comfortable you're going to kind of be with the calculator. So here we are, clear this out. The final question is, how many more insects does a large group have? Well, we have 12,800 insects here, and that difference, take away the 7,100, and here we are, we see we have a difference of 5,700. So that's the answer that we're going to be looking for. Okay? All right, you want to do the rest of the questions on this page in a similar fashion. Okay? Hope this quick video was a help.